Floor 13 is silent. Too silent. A night nurse sees a man. No name on the list. Entry badges say no one entered. Medication logs show no record. Security cams catch strange motion, but no face. Is it a ghost or something else? Step inside with me. Together, we will find the truth.
Hi, welcome to this crime case. We'll use real data to uncover the truth. Ready? Let's begin our investigation. First, we need to gather all our evidence. We'll load the entry badge records, medication logs, security camera motion data, and the patient list. Each one could hold a vital clue. Let's get everything on the table before we start connecting the dots. First things first, let's bring in our secret weapon. Pandas. This Python library is like our digital magnifying glass, letting us sift through all the evidence with ease. Now let's pull up the entry badge records. By reading in entry_badge_records.csv, we're about to see exactly who came and went from the building and when. This could be our first clue. Next, I'm loading up the medication logs. With meds_df, we'll be able to track every pill dispensed that night. Maybe someone tampered with the meds. Here comes the security cam motion data. By reading security_cam_motion.csv, we'll spot any unusual movements caught on camera. Sometimes the truth hides in the shadows. And finally, let's grab the patient list. This file tells us who was supposed to be in the building and who wasn't. Every name here could be a suspect or a witness. Let's see what we find. Now, let's take a quick look at each dataset. We want to see what kind of information we have. This helps us spot anything unusual right from the start. Let's start by printing out the entry badge records. This is our first look at who came and went on the night of the crime. Now, I'm calling badge_df.head, which shows us the top 5 entries in our badge data. Think of it as peeking at the first few pages of the guest log, just enough to spot anything unusual. Let's print out a headline so we know exactly what we're looking at. These are the medication logs, a key piece of evidence in our case. Now I'm calling meds_df.head. Let's start by shining a spotlight on the security camera footage. I'm printing a header so we know exactly what we're looking at. The motion detected by our cameras. Now I'm pulling up the first few rows of the motion_df data frame. This gives us a quick peek at the raw movement data. Maybe there's something unusual hiding in those early frames. Let's start by printing a fresh line and announcing our next move. We're about to reveal the patient list. This is where our suspects might be hiding. Now I'm calling patients_df.head. All our datasets have time columns. To compare events, we need to make sure these times are in the right format. This will help us line up the clues later. First things first, I'm importing the datetime module. We'll need this to crack open the exact times our suspects moved around. Every minute counts in this case. Here, I'm writing a function called parse_time. Think of it as our digital magnifying glass. It'll help us convert those messy time strings in our data into actual time objects Python can understand. That way, we can compare alibis down to the minute. Now I'm running parse_time on the badge_df. That's our log of who swiped in and out of the building. By cleaning up the time column, we'll see exactly when each person entered or left the scene. Next up, I'm doing the same for the meds_df. This is our medication log. Every pill dispensed is time-stamped. By parsing these times, we might spot if someone accessed the meds room at a suspicious hour. And finally, I'm parsing the motion_df. This one tracks movement sensors around the building. By lining up these times, we'll catch any sneaky late-night wanderers. Let's see if the timelines start to reveal a pattern. Now let's dig deeper. Who was actually in the East Wing when the strange sighting happened? Let's filter the badge records to find out. Let's start by narrowing down our search. Here, I'm creating a new set of records called East underline Wing underline entries. This line filters our badge data so we only see people who entered the East Wing, the scene of the crime. We're one step closer to finding out who was there when it all went down. Now, let's take a look at what we've got. By typing East underline Wing underline entries, we're pulling up the list of everyone who accessed the East Wing. This is our pool of suspects, and maybe, just maybe, the culprit is hiding in plain sight. Look closely at this clue. The badge records show Riley, Orderly Sam, and Dr. Chen were in the East Wing at different times. But do these times match up with the motion detected by the cameras? Let's find out. This is where things get interesting. Let's check the security camera motion data for the East Wing. Was there movement when no one used a badge? Let's start by narrowing our focus. Here, I'm creating a new variable called East underline motion. It's going to hold only the motion sensor records from the East Wing, but only where motion was actually detected. This way, we can zero in on any suspicious movement in that part of the building, right around the time of the crime. Now, let's take a look at what we found. By typing East underline motion, we're pulling up all those filtered records every time someone or something triggered the sensors in the East Wing. This could be our first big clue. Now, pay attention. Motion was detected at 22:07, 22:13, and 22:44. Do these times match any badge entries, or was someone moving around without a badge? Let's build a timeline. We'll compare badge entries and motion detections side by side. This will help us spot any gaps, times when someone was there but didn't use a badge. First things first, let's bring in our detectives toolkit. We're importing Pandas for wrangling the evidence, Plotly Express for visualizing the crime scene, and DateTime to help us piece together the timeline. Every good investigation starts with the right tools. Alright, time for some behind-the-scenes helpers. Think of these as our secret gadgets. They'll make sense as we dig deeper into the case. Here's a handy function called to and minutes. It takes a time and converts it into minutes since midnight. Why? Because when you're tracking movements in a building, every minute counts, and we want to compare everyone on the same scale. Now, we've got minutes, but we need to turn them back into actual timestamps. This function, minutes underline to underline dt, takes a list of minutes and a starting date, and gives us real date times. It's like reconstructing the exact moment each clue appeared. Let's get ready to transform our raw times into something we can actually use. We'll go from times to minutes and then to full date times, all to build a precise timeline of the crime. We'll set our base underline date to January 1st, 2000. This is just a reference point, a starting line for our timeline, so every event lines up perfectly. Now, let's take the badge entry times from the East underline Wing underline entries and convert them into minutes. This tells us exactly when each person swiped in, crucial for tracking their movements. Next up, we'll do the same for the motion sensor data in the East underline motion records. Every time the sensors picked up movement, we'll log it in minutes. This helps us spot any activity that doesn't match the badge records. With those minutes in hand, let's turn the badge entry times back into full date times. Now we can see the exact moments people entered down to the minute. And we'll do the same for the motion sensor times. This way, we can line up every movement with every badge swipe and start looking for gaps or overlaps. It's time to pull all our clues together. We're about to build one tidy data frame, a master list of every event in the East Wing, ready for us to analyze. Here, we're creating our data frame. We'll combine all the badge entry times and motion detection times into a single timeline and label each event by type. This way, we can see exactly what happened and when. And we'll close out our data frame setup. Now, every event, whether it's a badge swipe or a mysterious motion, is neatly organized for our investigation. Let's take a look at our finished data frame. This is our master timeline, every entry, every movement, all in one place. Now, we're ready to start searching for the moment the crime went down. Now, let's visualize the timeline. We'll plot both badge entries and motion detections together. This will help us see if anything doesn't add up. Let's start by setting the scene. We're about to plot a scatter chart using Plotly Express. This will help us visualize who was moving around the East Wing and when. Here, I'm creating a figure called Fig. We're mapping our data frame, DF, so the x-axis shows the exact time of each event, and the y-axis tells us whether it was a badge entry or a motion detection. I'm also coloring the points by type so we can spot patterns at a glance. The title, East Wing, badge entries versus motion detections. This is where our timeline of suspicious activity begins. And with that parenthesis, we're locking in all those settings. Our chart is ready to reveal its secrets. Now, to keep things clear, I'm making sure the categories on the y-axis are always in the same order. Badge entries on top, motion detections below. That way, we won't get confused as we hunt for clues. This line updates the y-axis, forcing it to show badge entry above motion detected. It's like stacking our evidence. First who came in, then what movement was picked up. Next, let's make the x-axis easy to read. We want to see the exact time down to the minute when each event happened. That's how we'll spot any odd gaps or overlaps. Here's a quick note. In Python, time is measured in milliseconds. So, to set our tick marks every 10 minutes, we multiply 10 by 60 by 1000. That's how we'll break the timeline into bite-sized chunks. Now I'm updating the x-axis. Each tick will show the hour and minute with a new mark every 10 minutes. I'm also turning on grid lines, dashed for a bit of drama, so it's easier to line up events and spot anything out of place. And with this parenthesis, those x-axis settings are set. Our timeline's coming into focus. If there's any data in our frame, I'm grabbing the earliest and latest times, xmin and xmax. Then I'm adding a 10-minute buffer on each side. That way, our chart isn't cramped, and we can see if anything happened just before or after the main events. Sometimes the real clue is in the margins. Let's polish up the chart's look. I'm setting the height, clearing out the legend title, and tightening the margins. It's like tidying up the evidence board before we call everyone in to take a look. And with this, the layout's locked in. Everything's in its place, ready for us to analyze. Finally, I'm showing the figure. Here's our timeline of badge entries and motion detections in the East Wing. Let's see if anything jumps out. Maybe the moment our suspect made their move. Look at the plot. Motion was detected at times when no badge entry was recorded. This suggests someone was in the East Wing without using a badge. Suspicious, right? Now let's check the patient list. Riley saw a man in a hospital gown. Could a patient be missing or unaccounted for? Let's see if the records match up. Let's start by taking a quick look at the first 5 rows of our patient's underlying DF data. This gives us a sneak peek at the people involved. Maybe one of them holds the key to our case. All patients are present and accounted for. The medication logs match the patient list. No extra patients appear in the records. So, who was the mystery man? Here's the final reveal. The data shows motion in the East Wing when no badge was used. All patients are accounted for. This supports Riley's story. Someone unaccounted for was there that night. Was it an intruder? Or something even stranger? The evidence is clear. Riley's sighting should not be ignored. Case closed. For now.